students, and welcome to the lecture on Quality Assurance and Control. After the lecture, we will be able to learn the following objectives. Discuss quality control and quality assurance. Understand the concept of total quality management. Define inspection. Discuss statistical process and statistical quality control. Explain acceptance sampling. Understand risk management. Discuss the International Quality Certification, ISO 9000 and ISO 14000. Define KAIZEN and Six Sigma concepts. Discuss network techniques. Let's start with a brief introduction to quality assurance and control. Quality is an important factor when it comes to any product or service. With the high market competition, quality has become the market differentiator for almost all products and services. Therefore, all manufacturers and services providers out there constantly look for ways to enhance their product or the service quality in order to maintain or enhance the quality of their offerings. Manufacturers will use two techniques. Let's discuss quality control and quality assurance. Quality control. In quality control, a verification process takes place. Certain activities and products are verified against a defined set of rules or standards. Every organization that practices QC needs to have a quality manual. The quality manual outlines the quality focus and the objectives in the organization. Quality assurance. Quality assurance team of the organization has many responsibilities. First and foremost, the responsibility is to define a process for achieving and improving quality. Difference between quality control and quality assurance. The following statements help differentiate quality control from quality assurance. Quality control is concerned with a specific product or service, and quality assurance is concerned with all of the products that will ever be produced by a process. QA does not assure quality. Rather, it creates and ensures the processes are being followed to assure quality. QC does not control quality. Rather, it measures quality. Quality control activities are focused on the deliverable itself. Quality assurance activities are focused on the processes used to create the deliverable. Quality control identifies defects for the primary purpose of correcting defects and also verifies whether specific attributes are in or not in a specific product or service. Quality control is the responsibility of the tester. Quality assurance is sometimes called quality control because it evaluates whether quality control is working. Quality assurance is preventing in nature, while quality control is detective in nature. The quality assurance teams of organizations constantly work to enhance the existing quality of products and services by optimizing the existing production processes and introducing new processes. Let's move to the next topic, which is the concept of total quality management. TQM is the foundation for activities which include commitment by senior management and all employees, meeting customer requirements, reducing development cycle times, just-in-time demand flow manufacturing, improvement teams, reducing product and service costs, systems to facilitate improvement, line management ownership, employee involvement and empowerment. An inspection determines if material or an item is in proper quantity and condition, and if it conforms to the applicable or specified requirements. Inspection is generally divided into three categories: receiving inspection, in-process inspection, and final inspection. Inspection fields. There are many fields of inspection. Government. In government and politics, an inspection is the act of a monitoring authority administering an official review of various criteria that are deemed by the authority to be related to the inspection. Business. In international trade, several destination countries require pre-shipment inspection. The importer instructs the shipper which inspection company should be used. Road vehicles. A vehicle inspection, for example. An annual inspection is a necessary inspection required on vehicles to conform to laws regarding safety, emissions, or both. It consists of an examination of a vehicle's components, usually done by a certified mechanic. Engineering mechanics. Quality-related inspection is an essential part of quality control. A mechanical inspection is usually undertaken to ensure the safety or reliability of structures or machinery. Medical. A medical inspection is the thorough and unhurried visualization of a patient. This requires the use of the naked eye. Military. An examination vessel is a craft used to inspect ships entering or leaving a port. Real estate. A property inspection is the examination for purposes of evaluating a property's condition. In purchasing property, a whole house inspection tries to detect defects in the property. Software engineering. Software inspection in software engineering refers to peer review of any work product by trained individuals who look for defects using a well-defined process. Now let's talk about the statistical process and statistical quality control. In statistical process control, or SPC, and statistical quality control, or SQC, one gets processes of higher efficiency with improved quality levels. These form the foundation of process improvement, giving a competitive advantage. Control chart. The control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a central line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. When to use a control chart? When controlling ongoing processes by finding and correcting problems as they occur. When predicting the expected range of outcomes from a process. When determining whether a process is stable in statistical control. When analyzing patterns of process variation from special causes, non-routine events, or common causes built into the process. When determining whether the quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. Control chart basic procedure. Choose the appropriate control chart for the data. Determine the appropriate time period for collecting and plotting data. Collect data, construct the chart, and analyze the data. Look for out-of-control signals on the control chart. When one is identified, mark it on the chart and investigate the cause. Out-of-control signals. A single point outside the control limits. 2 out of 3 successive points are on the same side of the center line and farther than 2 sigma from it. 4 out of 5 successive points are on the same side of the center line and farther than 1 from it. A run of 8 in a row are on the same side of the center line, or 10 out of 11, 12 out of 14, or 16 out of 20. Obvious, consistent, or persistent patterns that suggest something unusual about the data and process. Acceptance sampling is a method used to determine if one accepts or rejects a particular product. This is done by first establishing an acceptance plan or sampling plan, which sets the product acceptability criteria. This is known as the decision rule. Conditions for using acceptance sampling. There are situations when 100% sampling is not practical. Some of these situations are when the testing results in the destruction of the material, when there is a high cost involved for the inspection, when there are time or technology constraints, when the size of the lot is large and the chances of making inspection error is high, when the supplier has been very reliable in producing goods that are within the inspection criteria. Steps for acceptance sampling. The basic steps followed for acceptance sampling are: for batch processes, lot is received from the production line. A random sample is taken from the batch. The sample is analyzed and checked whether it meets the acceptance criteria. If the sample meets the acceptance criteria, the batch is accepted and sent for further processing. If the sample fails to meet the criteria, the batch will be removed and evaluated, determining the next step for that particular batch. For continuous processes, sample is taken from process line at a certain frequency. The sample is analyzed and checked whether it meets the acceptance criteria. If the sample meets the acceptance criteria, then continue to accept products. If the sample fails to meet the criteria, then that particular group of out-of products will be separated and evaluated, determining the next step for that particular group of products. Now let's talk about risk management. Risk management is not new to the quality and compliance industry. Risk has always been a prominent feature in standards such as ISO 13485, ISO 14971, and ISO 31000. Risk management methods are typically defined as the ability to detect and then evaluate and control potential risks. cost of quality. This is a term that is widely used and widely misunderstood. The cost of quality is not the price of creating a quality product or service. Historical views of quality gurus about cost of quality. Historically, business managers have assumed that increased quality is accompanied by increased cost. Higher quality meant higher cost. In 1979, Crosby introduced the new popular concept that quality is free. 3 different views held by the management professionals about the cost of quality. Today's view of quality cost among practitioners seems to fall into 3 categories. Higher quality means higher cost. The cost of improving quality is less than the resultant savings. Quality costs are those incurred in excess of those that would have been incurred if products were built or services performed exactly right the first time. Categorization of quality costs. The cost of quality is generally classified into 4 categories: external failure cost, internal failure cost, inspection or appraisal cost, prevention cost. ISO 14000 is a family of standards related to environmental management that exists to help organizations minimize how their operations, processes, etc. negatively affect the environment, for example, because adverse changes to air, water, or land, comply with applicable laws, regulations, and other environmentally oriented requirements, and continually improve in the above. Benefits of ISO standards. ISO international standards ensure that products and services are safe, reliable, and of good quality. For business, they are strategic tools that reduce costs by minimizing waste and errors and increasing productivity. Now let's explore the Kaizen and Six Sigma concepts. Kaizen is an ancient Japanese philosophy that strives to continually improve all aspects of a person's life. The Japanese workforce first used it in business shortly after World War II. The function. Kaizen looks to improve all aspects of a business through standardizing processes, increasing efficiency, and eliminating waste. Six Sigma focuses more on improving the quality of the final product by finding and eliminating causes of defects, whether by variances in the business process or in manufacturing. Facts. Kaizen focuses on improvement, looking at every employee from top management to entry-level positions. Sigma is a mathematical term that measures a process deviation from perfection. Differences. Six Sigma uses more statistical analysis than Kaizen. Six Sigma aims for as close to 0 defects as possible, calling for a maximum of 3.4 defects for every million opportunities, which creates a 99.9997% success rate. Benefits. Six Sigma and Kaizen help save money for companies. Motorola has reported saving $17 billion since 2006 because of Six Sigma. More than half of the Fortune 500 companies use Six Sigma, including General Electric and Honeywell. There are 2 network techniques: Critical Path Method, or CPM, Project Evaluation and Review Technique, or PERT. Critical Path Method. Tool to analyze project and determine duration based on identification of critical path through an activity network. Knowledge of the critical path can permit management of the project to change duration. A single estimate for activity time was used that did not allow for variation in activity times. Activity times are assumed to be known or predictable, deterministic. Activities are represented as nodes or circles. Project evaluation and review technique. Another derivative of the Gantt chart. Multiple time estimates were used for each activity that allowed for variation in activity times. Activity times are assumed to be random with assumed probability distribution, probabilistic. Activities are represented by arrowed lines between the nodes or circles. Project scheduling by PERT and CPM. It consists of three basic phases: planning, scheduling, and controlling. Project planning. The various steps involved during this phase are: identify various activities, task or work elements to be performed in the project. Determining requirement of resources such as men, materials, machines, etc. for carrying out activities listed above. Estimating costs and times for various activities. Specifying the interrelationship among various activities. Developing a network diagram showing the sequential interrelationships between the various activities. Scheduling. Once the planning phase is over, scheduling of the project is when each of the activities required to be performed is taken up. The various steps involved during this phase are: estimating the durations of activities, taking into consideration the resources required for these executions in the most economic manner. Based on these estimates of time, preparing a time chart showing the start and finish times for each activity, and hence calculation of total project duration by applying network analysis techniques such as forward or backward pass and floats calculation. Project control. Project control refers to re-evaluating actual progress against the plan. If significant differences are observed, then rescheduling must be done to update and revise the uncompleted part of the project. PERT and CPM network components and precedent relationship. PERT and CPM networks consist of two major components: events. An event represents a point in time that signifies the completion of some activities and the beginning of new ones. Activities. Activities of the network represent project operations or tasks to be conducted. Let's move on to the safety management systems. Safety Management System, or SMS, is a term used to refer to a comprehensive business management system designed to manage safety elements in the workplace. International Labour Organization SMS model. In the ILO document, ILO-OSH 2001 Guidelines on Occupational Safety and Health Management Systems, the safety management basic components are: policy, organizing, planning and implementing, evaluation, action for improvement. Adoption of SMS for industry sectors. There are a number of industry sectors worldwide which have recognized the benefits of effective safety management. The regulatory authorities for these industries have developed safety management systems specific to their own industries and requirements, often backed up by regulation. Civil aviation. The International Civil Aviation Organization has recommended that all aviation authorities implement SMS regulatory structures. The ICAO has provided resources to assist with implementation, including the ICAO Safety Management Manual. Maritime industry. The International Maritime Organization, or IMO, is another organization that has adopted SMS. All international passenger ships and oil tankers, chemical tankers, gas carriers, bulk carriers, and cargo ships of 500 gross tons or more are required to have a safety management system. Railway industry. The Rail Safety Management System requirements are set out in the Railway Safety Management System regulations. The objectives of the Rail Safety Management System regulations are to ensure that safety is given management time and corporate resources. Now in the end, let us summarize what we have learned in this lecture. Quality assurance is a broad practice used for assuring the quality of products or services. There are many differences between quality control and quality assurance. In quality assurance, a constant effort is made to enhance the quality practices in the organization. ISO international standards ensure that products and services are safe, reliable, and of good quality. For business, they are strategic tools that reduce costs by minimizing waste and errors and increasing productivity. Total quality management views an organization as a collection of processes. It maintains that organizations must strive to continuously improve these processes by incorporating the knowledge and experiences of workers. Safety Management System, or SMS, is used to refer to a comprehensive business management system designed to manage safety elements in the workplace.